Good day, folks. Welcome to my YouTube channel. Guys, I'd like to thank you so much for the support. I've seen your subscription, I've seen your likes, your views, your comment. Guys, please continue to support me. Watch all my videos, like the videos, and share with your families and friends. Thank you so much, guys. It really means a lot. Continue to support me. Thank you. Now, today's lesson is about vertical projectile of motion. So we're dealing with the movement vertically, something that is thrown, something that is released vertically, which means up and down. Now, in this topic, you need to understand what is projectile, right? What is a projectile? According to the exam guideline, guys, the projectile, it says it's an object which has been given an initial velocity and it moves under the influence of gravitational force only. Guys, that's self-explanatory. Whenever you define a projectile, it's an object that is given an initial velocity that is under the influence of gravitational force only, no other force that should act on an object. And one thing that we need to note, guys, the gravitational force in the vertical projectile of motion, the only force that is acting is the gravitational force, and the gravitational force is what? Is downwards. It's acting downwards all the time, the gravitational force, right? Even the gravitational acceleration, which is 9.8 meter per second square, it's always downwards. And another concept or another definition that you need to understand in this topic, it's a free fall. A free fall. A free fall, according to an exam guideline, it says a motion. It is a motion, is not an object, just like a projectile. It's a motion during which the only force acting on an object is the gravitational force only. It's a motion. Guys, let's look at the scenario number one. I'm going to present the scenario when an object is dropped from a certain height. Now, when an object is dropped from a certain height, guys, what is very important, you need to visualize it and understand what is happening. Let's say this is the height. This is the height of a, let's say, a building, and this is the ground. This object is dropped from here, right? The direction of the object is going to go downwards. So we're going to choose downward as what? As positive, right? Since the object is going to go down. So guys, whenever an object is dropped, its initial velocity is what? Is 0 all the time. When an object is dropped, they can use the word released. So its initial velocity is always 0. So as the object it goes down, the velocity increases. It's very important. It increases by what? 9.8 meters per second square. Now we choose, as I said, we choose downward as positive. That means our gravitational acceleration, it will be what? It will be 9.8, right? It will be 9.8, positive 9.8 meters per second. And that's very important. So up, that means up will be what? Will be negative. That is very important. Now it has the object, it has initial velocity that is 0, and it has its final velocity before it hits the ground, and we do not know. And it took time while it's in the air before it hits the ground. We do not know the time. You will be able to calculate that time. And of course the height, which is the displacement that it traveled from the height of the building to the bottom. It's changing y, and it's going to be positive because the object is displaced in a positive direction. Now let's look at graphically. How are we going to plot that graphically? So our graph, it's a velocity, it's a displacement over time graph, displacement versus time graph. So we'll have a displacement there in meters, and we'll have change in time there in second. So our graph that shows the displacement of that object is going to be like this. It's going to be a curve. The curve of that, because while the displacement, which is the distance it traveled, it increases, also time lapses there. It's going to be a curve like that. Now when you choose upward as positive, guys, we have a choice here. When you choose up as positive, that means your 9.8 will be what? Will be negative. So you graph this curve of position versus time. This is position versus time, will be in the negative. This is the negative, guys. This is the positive. So it will be under the x-axis. This one is above the x-axis, this one. So this one will be under the x-axis. It will be like that. It will be a curve like that, similar curve, but below the x-axis. Now let's look at the velocity time graph. The velocity time graph, guys, you need to understand that what I've mentioned earlier, that as an object is moving downwards, its velocity increases as the time lapses. So our graph here, it will be velocity here in the y-axis, in the x-axis here it will be time. So since it started with the velocity 0 there, which is the initial velocity, so our graph here will cut through the origin. So as the time lapses, the velocity increases as it goes down, so it will be a straight line like that, right? So in this graph, guys, whenever they talk about this graph, when they talk about the gradient, this is a straight line. A straight line, it consists of the gradient. So the gradient here, it's m, it's going to be the change in v over change in time, from the gradient, which is change in y over change in x. So change in y, our y is going to be velocity, and our change in x is going to be time. So that means our gradient here is what? Is acceleration. So all the time, guys, when you're given the velocity time graph, the gradient here is the what? Is the acceleration, and it's constant, and the acceleration here, it's 9.8, right? So guys, the area, let's say the graph, the time here, it ends there. So the area under this curve, guys, when we talk about this area, this is a right angle triangle. So the area under this curve, it's a what? Since it's a right angle triangle, guys, it's half base times height. So our base here is what? Is time. Let me write it here. Area here, it's going to be half base times height. Our base here is what? Is time. And our height is what? Is velocity there. It's going to be velocity there. Let me remove the change. It's time multiplied by velocity. So the v multiplied by t, it's going to be the change in y. So this simply means that the area under this curve, it tells us about the what? The displacement. The displacement it has traveled to this object there, right? Same applies, guys, when you choose upward is positive, your curve will be like this. It will be a curve like this, and the area under that curve, it will be a displacement from the top of the height till it falls into the ground, guys. As let's go to the acceleration time graph. Remember, the acceleration here, it's constant in the vertical projectile of motion. It's 9.8. So the acceleration here is 9.8, and we chose it down as positive in this scenario. So our down is positive, so your curve, it will be like this. It will be a straight line that is 9.8 there, right? Now let's look at when you chose upward as positive while the object is going down. If you chose upward as positive, your acceleration is always going down. It will be below the x-axis. It will be the straight line like this. That is 9.8. Always, guys, in the acceleration time graph, it's a straight line, which is 9.8. Let's look at the similar example from the above introduction of the object that is dropped. It says a ball is dropped. Now, when you are told that the ball is dropped, you must know its initial velocity is what? Is 0 from the top of the building. Building, that is the height, so that's the displacement. And another thing that is very important here is to choose, as the object is going down, we'll choose downward as what? As positive. That means our 9.8 here, it's positive 9.8 meters per second square, right? Ignore the effect of the air resistance. 7.1, it says define the term free fall. A free fall, as I've mentioned before, it's a motion of an object under the influence of gravitational force only, or the weight only. Motion in which the only force that is acting is the gravitational force. 7.2, it says calculate the speed at which the ball hits the ground. So what do we have? We have, as the ball, we have the initial velocity here is 0, and as the object goes down, increases its velocity, and before it hits the ground, it has the final velocity there. So we wanted that velocity. Do we have the time while it's in the air? We do not have. We have the displacement here. The displacement is what? Is 20. Guys, let me write it clearly. We have the initial velocity is 0, and the final velocity is the one that we're looking for. We have the time? No, we are not given the time. The displacement, we have the displacement, and it's going to be positive 20 because it's going downwards in a positive direction. So which formula are we going to use? Now, we have different formulas. These are the formulas that we're going to choose from in answering this question. It wants the final velocity, we have the initial velocity, and we do not have time, and we have the displacement. So the formula that we will use here, it's this one. Why are we going to use that one? Because we want the final velocity and the initial velocity we do have the acceleration and the displacement we do have. So we're going to use this formula, and I'm not implying that is the only formula. So we want the final velocity. So since it's a square root there, the initial velocity there, it's what? It's 0. And the acceleration there, it's positive 9.8. I forgot to rewrite it. It's positive 9.8 meters per second square. And the displacement is 20. So when you put that under the square root there, your answer there of the final velocity will be 19.8 meters per second. There will be what? Downwards. So That question is out of 4 marks, so it will be 1 mark, 1 mark for the substitution of that, and also substituting 20, and your 19.8 with units meters per second. Now let's go to 7.2. 7.3, sorry, 7.3, it says calculate the time it takes for the ball to reach the ground. Now that we have the initial velocity and the final velocity and the displacement and g, which is the 9.8, which formula can we use to calculate the time it took there? So out of these formulas, I think this one will be the first one there. It will be the easiest. We have the final velocity, we have the initial velocity, we have the acceleration. We're looking for time. So our final velocity there, it's positive 9.8, initial velocity is 0, and our acceleration, because we chose down as positive, is going to be positive 9.8, and we want time there. So this is going to be 9.8 change in t and 19.8, and we divide by 9.8 both sides. 9.8, since we want time as the subject of the formula. So our answer there is going to be 2,02 seconds. That's not the only way to calculate that, but I'll use that. Now 7.4, it says sketch velocity time graph for the motion of the ball. Values are not required. So your graph, it's going to be like that. So it's very important to label your x-axis. My y-axis will be velocity meters per second and time in what? In second. Since we chose down as positive, so our graph will be above the x-axis, and it started with the initial velocity and ended up with the final velocity, that is 19.8. So if it started with the initial velocity at 0 and it was dropped, it will cut through the origin, a straight line like that. Remember, they said we should not no values are required there. Let's look at an example where an object is thrown vertical upwards and returned to the starting point. It says a ball is thrown vertical upwards at 4 meters per second, and this is the initial velocity, right? Guys, whenever it's the object is thrown or projected, the initial velocity is not going to be 0, right? And it returns to thrower's hands, right? So it will take this motion, guys. It will be this motion, right? So the initial velocity is what here? Is 4, and therefore the final velocity will be what? Will be 4. But now let's choose. Oh, we are told here. It says let the direction of the motion downwards to be positive. So we're told here positive. Downwards should be what? Positive. So as it goes up, so the initial velocity, so it's going up the ball, the initial velocity will be negative, and then as it goes down, it goes up, and it reaches there, the final velocity is what? Is 0. And as it goes down, increases the velocity, so it's going in the positive direction. This is the negative direction, as we're told there, right? Now the question, now it says calculated the maximum height the ball reached. Now this is 2.1. It's very important to write what you have. Okay, so we're going to use the segment from here to here to calculate from the initial point to the maximum point. What do we have there? We have the initial velocity, that is negative 4 meters per second, which is upwards, and also the final velocity at the maximum point, at the maximum height, and the displacement at the maximum height we do not have, but what we know, it's going to be negative, and the time from the starting point to the maximum point we do not know. So we're going to use which equation to calculate the time that has been taken? We're going to use the equation that says vf square v initial square plus 2a change in y. The reason we use this equation, we are looking for this. We have an acceleration, we have an initial velocity, we have the final velocity. At the maximum point is 0. So the final velocity is what? Is 0, and the initial velocity is negative 4 square plus 2a, and the acceleration, since we have chosen, we're told that downward is positive, it's going to be positive 9.8 change in y. So it's going to be, when we take this to this side, it's going to be negative 16, 4 squared is 16, and it's going to be positive 16 on this side, and this is going to be 19.6 change in y. And then we'll divide by 19.6 both sides. Therefore, our change in y is going to be negative. As I've mentioned here, our change in y is going to be negative. So it's 16 divided by 19.6. So the answer here, it's negative 0.82 meters. So the interpretation of that negative, it's 0.82 meters upwards, because when we use the initial velocity at 4 and the final velocity is as 0, so that means it's moving from the starting point to the maximum height, as I've mentioned. All right, let's go to the following question, 2.2. 2.2, it says the total time taken for the ball to reach its highest point in its trajectory. So now we have the displacement. What do we have in this case? We have the displacement, which is negative 0.82, and we're looking for time. So from this trajectory, from the initial point to the maximum or the highest point, so the final velocity there is what? Is 0. The initial is negative 4 meters per second. So we are looking for time. So we can use this equation that says Vf is equal to V initial plus a change in t. That's the easiest to use this one. So the final velocity there is 0, initial is negative 4, plus the acceleration is positive 9.8, and we are looking for time. So we transpose this to that side, it will be 4, and 9.8 change in t, we're going to divide by 9.8 both sides. So it's going to be change in t there, it's 4 in the calculator, divide by 9.8, it's 0.41 seconds. I guess there's another way to calculate that. Yes, so if we can use this formula that says change in y is equal to v final plus v initial over 2 multiplied by change in time. So we're using the same segment from the starting point to the maximum point. The displacement there, it's 0.82 equal to the final velocity 0, and the initial velocity is negative 4 divided by 2 change in time. Let's put this here. Okay, so we'll say 0.82 equal to negative 4 divided by 2 change in time is the answer there. So it will be negative 2 change in t, 0.82 change in t. As you can see, it will give the same answer. We divide by negative 2, divide by negative 2. So our change in t here, it's going to be 0.41 seconds. Right? Let's answer 2.3. 2.3, it says calculate the total time that the ball is in the air. So we have seen the time from here, from the initial point to the maximum point, it's what? It's 0.41 the time. Similarly, the time from the maximum point to the starting point, returning to the starting point, it will be 0.41. So what we can say here, 2.3 2.3, we can say total time, it will be 0.41 times 2, it will be 0.82 seconds. 2.4, what is 2.4? 2.4, it says the total displacement during the motion. During this motion, the displacement, it's what? So we had our change in y here, it was negative, and our change in y here, it was positive. Remember, we chose up as positive and down as negative. So the change, the displacement there is going to be what? 0 meters, because it comes from when we wanted the change in y, so it's going to be the negative y plus the positive y, which is the displacement from there. It's going to be negative 0.82 plus 0.82, that will give us 0. It comes from that to this. This scenario is when an object is thrown into the air and falls beyond its starting point. Like, let's say this is a height, right? This is a building. So the object is thrown here and it moves upwards and it reaches maximum height, and it goes beyond, it passes the starting point and it goes beyond the starting point and reaches the ground. So these are the things that we need to touch on. So again, when it's thrown an object, the initial velocity is not equal to 0. So it's thrown here with a velocity and it's going upwards. Let's say if we choose upwards as positive. So if we choose upwards as positive, that means our 9.8 will be negative. So the velocity decreases and reach the maximum height where the velocity is what? Is 0 there, right? And the velocity, it's in the positive direction. And then from the maximum point downwards, the velocity here, it increases. It increases the velocity here, it decreases, right? It decreases in the negative direction, and it passes the starting point. Remember, when it passes the starting point again, the velocities are the same. This velocity here is the same as the velocity here, but in opposite direction. This one will be negative and this one will be positive. The velocity it was thrown, let's say it was thrown at 10 meters per second. So when it passes the starting point, the velocity here will be the same. It will be 10, but a negative 10. And then it increases further the velocity. And before it hits the ground, there's the final velocity. And that final velocity is negative, right? Now, let's look at the graphs. The graph of that, the position versus time graph, of that, it will be the same. It will be the same. Let's look at it. Now, if we plot that as we chose upward as positive, so our graph, it's going to be like this. It will represent the same motion there. It will be like this, right? It will be like that. And if we choose the starting point as the height of the cliff, the starting point is, or we choose the height of the cliff as the reference point. But if we choose the ground as the reference point, your graph, it will be like this, right? Your graph will be like that. Same downward is, upwards is still positive there. That's your position versus time graph. Remember, your graph, it must be labeled, your y in meters and your time in seconds. Same with this one, your time in seconds there. Now let's look at your okay, let's look at when we chose downward as positive. Therefore our acceleration will be positive and our graph will be, if we choose the height of the cliff as a starting point, so our graph will start below the x-axis. It will be a graph like that, right? And then here our graph, if we choose the ground as a reference point, so our graph will be like this, right? It will be a graph like that. Now let's look at the velocity time graph as we choose upward as positive. Our velocity time graph, the object is thrown with an initial velocity, and we said that this initial velocity here at the top of the cliff is positive, and it's, as it moves up, it's positive. So it's going to start above the x-axis, it's positive, and your graph will reach the maximum height there. This is the maximum height where the velocity is 0, and then from the maximum height it goes down and the velocity increases in the negative direction, so it will be like this. Your graph go further like this. So you label your axis, it's velocity meters per second, and time in seconds there. And then your acceleration time graph, it's going to be below the x-axis because our acceleration is negative because we chose upward as positive, so it will be a straight line like that. Now let's look at the velocity time graph. When we chose downward as positive, it will start below the x-axis, so the acceleration there will be negative, and the initial acceleration, and it goes to a maximum height where your velocity is 0, and then from the maximum height it continues further down there, right? Yeah, the gradient here, it says a negative gradient. We know in mathematically when we have a straight line like that, our gradient is negative and it's 9.8, right? And yeah, and if you look at this, we have two triangles. We have this triangle and the smaller triangle. So if you subtract the two triangles there, which is you subtract the areas, and you say the area of the big triangle minus the area of the small triangle, it will give you the height of the cliff. It will give you the height of the cliff. Let me say it in a different way. Let's say this is an area of a big triangle, and let's use green. This is the area of the small triangle. Remember, in the previous example, I told you the area under the curve, it represents the displacement, the object that it has traveled. So if the height of the cliff, we calculated the height by saying the area, let me take blue, the area, let me take blue, the area of the big triangle, which is blue, area of the big triangle, which is the blue one, minus the area of the small triangle, which is the green one. Right? So those two areas, they represent the displacement. They represent the displacement. So the area, we know the area, it's going to be half base times height, minus half base times height. So our base, half base, our base here, it's going, in the big triangle, it's going to be time. So it's going to be time multiplied by height. The height there, it's going to be what? The velocity, minus, in the small triangle, the base also there, it's going to be what? The base is going to be what? Time. And the height will be velocity as well there. So it will tell us the height of the cliff. This answer will be in meters. As the cliff there, the object is projected vertically upwards and it goes to the ground and passes the starting point. So the small triangle here, the small triangle is this part, and then the big triangle is this part. So when we say this minus this, it will give us the height of the cliff. This long minus this small, and it will give us the, so those are the areas. Remember, I told you the area represented the displacement, which is this displacement and this displacement. Let's look at an example where the object is thrown from a height and it passes at the starting point to the ground. Now this is question 14. Now it says a ball is thrown vertically upwards with a velocity v. Remember, this velocity is not equal to 0. That's the initial velocity in which the ball was thrown. And it says from the edge of the roof of 40-meter tall building. So this ball is thrown from here. So it will go this way, downwards, right? So now it says the ball, it takes 1.53 seconds to reach its maximum height. So the ball from here to here, it takes what? 1.53 seconds, right? Now what you need to understand again here is that the ball, it is thrown with the velocity v. We're not given the velocity there, which is an unknown, and it decreases and reach the maximum height, and we are told at the time that it took there. So at maximum height, the final velocity there is what? Is 0, right? And the velocity here is v, is an unknown. So, and then the ball goes back to the starting point, and then it will reach this point with the same velocity it was thrown. So it's going to be negative v. The same velocity where it was thrown, it will be negative v, and then it goes down again and increasing in velocity. The velocity here, from the maximum point till it reaches the ground, the velocity increases. The velocity in this side, it would decreases, right? Okay, let me try to tighten here, right? Okay, now also we have to choose the direction. Since the ball, its motion, it's up, so I'll choose up as positive. So up is positive, and then that means downwards will be negative. That means our gravitational acceleration here, which is a, it's going to be negative 9.8 meters per second square, right? Now 14.1, it says define the term free fall. Remember, the free fall, it's a motion in which an object has the only force that is acting on it, it's the gravitational force. It's a motion in which the only force acting on it is the gravitational force. So 14.2.1, calculated the magnitude of the initial velocity. It's very important to choose which segment are you going to take to calculate that. So I'm going to take this segment from here to the maximum height. So from the top of the roof to the maximum height, what do I have there? I want v, which is v is the initial velocity. V is the initial velocity. I wanted that v. And then what else do I have? I have time, it's 1.53 seconds, and I do not have the displacement from the top of the roof to the maximum, so I know it's going to be positive, but I do not have. And I have the final velocity at maximum height is equal to 0. So which formula I'm going to use to calculate the initial velocity there? So the formula that I'm going to use, it's simple. It's this one: v final is equal to v initial plus acceleration times change in time. I choose this formula based on what I have, because I have the final velocity, which is this one, and the initial velocity is what I'm looking for, and the acceleration, I do have it, and the time, I have it, from here to the maximum point. Okay, let's substitute now. So the final velocity is 0, the initial velocity is v, plus the acceleration is what? It's negative 9.8, as I've mentioned before, because we chose up as positive, and the time is 1.53. So when I take v to that side, it will be negative v, and then when I punch that in the calculator, 9.8 times 1.53, so the answer there, it will be negative 14.99 meters per second. Since it's both negative, we'll divide by negative, therefore v, it will be 14.99 meter per second. Alright, it's positive because it was going up, and we chose up as positive, so it's upwards, so there's no need to write the direction there. Now let's look at 14.2.2. It says calculate the maximum height by the ball above the edge of the roof. So we wanted this height from the edge of the roof to the maximum height where the velocity is 0. So this is 14.2.2. Okay, let me write it here, 14.2.2. So what do we have there? We have the initial velocity, which is 14.99 meters per second, and the final velocity at maximum point at 0, and then the time is 1.53 seconds. And what else do we have? The acceleration is negative 9.8 meters per second. And what do we want? We want the maximum height. It's positive, right? So the formula that we're going to use there, it's going to be this one that says Vf squared equal to V initial squared plus 2 times acceleration change in y. Why are we using this one? We have the final velocity is what? Is 0, and the initial velocity, we do have it, is that one, and the acceleration, and we want that one. And there's so many formulas that you can use there. Okay, the final velocity is 0. 0 square is equal to the initial velocity, it's 14.99, and it's positive square plus 2a. The acceleration, it's 9.8, the negative 1, and change in y. So I will take this to this side. It will be negative 14.99 square equal to 19.6 change in y, and then we divide by 19.6, negative 19.6 both sides. So our change in y, it's going to be positive, as I've mentioned before. So it's 14.99 square, we divide by 19.6. The answer is 11.46 meters, right? That's the answer. So I'm not gonna, you can also get the answer using this formula that says change in y, vi change in t plus half a change in t squared. Why? Because we want this, we have the initial velocity and time, acceleration and time. You can get the same answer using that. Let's go to the next question. The next question, it says which is 14.3. 14.3, it says take the edge of the roof as the reference point. So they said the edge of the roof is the reference point. That means it's a 0 point, it's a starting point. Determine the position of the ball relative to the edge of the roof after 4 seconds. So in other words, it's asking from here as a starting point, where will be the ball after 4 seconds? So simply what we're going to do here, we're going to use this equation here. So that's 14.3. We're going to use this equation and determine where will be the ball. So we will use this exactly this, but the same way we were going to use in this, but with only the difference there, it will be time. So we'll say change in y, v times I. So this formula, so let's substitute. We wanted the displacement, so the velocity, it's still 14,99, and the time now it's 4 seconds, and at the displacement it must be negative because the ball is going downwards. It will be going downwards because the displacement from here to here, okay, let me use another pen. The displacement from here to here, from here, the displacement here is what? Is 0. So the ball will be somewhere here. The ball will be somewhere there. It will be negative because it's going downwards, which shows upwards as positive. So half 9.8, the time is 4, right? So if we punch that in the calculator, so we'll have 14,99 times 4 plus half times negative 9.8, 4 square. So the answer here is negative 18, 44 meters. This simply means that it's 18,44 meters downwards. As I've mentioned, that the ball, it will be going downwards, so it will be somewhere here. 18 probably will be, the ball will be somewhere there. This will be 0 point, it will be somewhere there, which is, it's 18,44, this displacement. Let's go to the last question, the 14,4. It says, will any of the answers to question 3.2 and 3.3, so they mean 14.2 and 14.3. It's supposed to be 14.2 and 14.3. Change. So will the answers in those questions change if the height of the building is reduced to 30 meters? So the answer here is no. What will be the reason? Now the reason is that those answers won't change as long as the initial velocity does not change. So the height, those answers will change as long as the initial velocity is not changed. They won't change.